Let's talk about our spreadsheet homework. We're going to go to this expected value spreadsheet assignment and download the file. This is what it looks like. This refers back to the example that we did in our book on page 285 with the pick-a-ducks. So in our book, they have an example of 50 ducks, and it's $1 to play, and then each duck has a different dot on the bottom that corresponds to a different value of prize. So what you're going to do is design your own version of this pick-a-duck game, but it needs to be significantly different from the one in the book. Don't just copy the one in the book, make up your own. So you're going to put in your colors. And then decide how many of these ducks will there be. And we want to use formulas and functions everywhere possible so that we can go back and change things and it'll adjust. So instead of adding up on paper the number of total ducks and typing it in, I want to use a formula, a sum formula, for my total number of ducks. So equals, and I'm going to use the sum function of all of these ducks. And then I want to have Excel tell me what the probability is of each type of duck. So let's see, if the gold duck, there's one of those, and the probability would be the number of gold ducks divided by the total number of ducks. There's my probability. Now, I could drag this down and autofill it, but I can see there's a problem here. When I click on it, I look and see, oh, the formula is taking the total and trying to go down to the cell below it. I don't want that. Escape. So I'm going to go up here, and where I'm taking the number of ducks divided by the total, each time I want to use that same total. So I'm going to use an absolute cell reference, putting those dollar signs. Now remember, you can go down below in the spreadsheet assignment to all of those help videos and look for something on spreadsheet functions, spreadsheet formulas, absolute cell references, any of these things that you need to see more about. That's available. So now that I've made it have an absolute reference here where no matter if I'm pulling it down, this thing's not going to move. Let's see if that looks a little better. Great. Click on this and check it. Yes, the probability should be 30 divided by this total number. Great, so I hit escape to get out. So then I just decide how much is this prize going to cost me. Let's say the gold duck is a $100 prize. And I'd like to make that currency. In fact, I'd like to make all of these currency. Okay, so then these other prizes I don't want to be nearly as much. Maybe a 1-cent sticker, a 5-cent something. So the way that this is set up is that it's looking at it from the perspective of the operator of the game. In the book, it was from the perspective of the customer. So the profit, so these costs, and then profit is going to be hopefully a positive number for me. For the game player, if the prize they're getting is less than the cost to play, then it would be negative. Like in our example, most of them were. So at this point, to figure out profit, I need to decide on a ticket price. Let's say $2. And I'll change that into currency. Okay, so the profit would be the ticket price, which, once again, I want to be an absolute cell reference, minus the cost of the prize. So if they get the gold duck, I'm out $98. However, on all the other ones, I'm making a profit. So the expected value for each time the game is played, remember we're going to take the value times the probability, value times probability, value times probability, and add all those up together. So value times probability plus value times probability plus value times probability. Okay, now the expected value should be also money. We'll change that to currency. So in the long run, with each time this game is played, I'm expecting to make a profit of $1.12. Now, all these things that we're doing, you'll be walked through on these steps over here. Okay, step 13. Finally, suppose this carnival is for charity. You want the ticket price to be affordable, but you also want an expected value of at least 50 cents to play. Go back and adjust your numbers until you achieve this. So, on the numbers that you did, if you don't have at least a 50-cent expected value, if you're not making at least 50 cents off of each play, you might need to change things. For example, if I had had 5 gold ducks, then in the long run, I'm losing over $2 per play. So I need to change this. Maybe just 2 gold ducks still isn't enough. Now, I could leave that 2 gold ducks, and I could increase the number of black ducks if I wanted to. What if there were 100 black ducks? Well, hey, that fixes it too. So you've got lots of options. As long as you've got all of your formulas built into the sheet, you should be able to change your number of ducks, or you could change the cost of the prize in order to adjust to get the expected value that you want. Then finally, you're going to figure what do you expect as your profit if it's played 50 times. So make sure that when you're doing yours, don't do the same one as mine, and don't do the same one as in the book. Do your own, but I know you'll do great.